Hi everyone, welcome back to Beginning Algebra, and today we're in section 5.4 where we're talking about adding and subtracting polynomials. Today I'm going to give you just a little bit of vocabulary that we use when we're talking about polynomials, and we'll practice evaluating polynomials, we'll add and subtract them, and then we'll talk about adding and subtracting polynomials with more than one variable. Today's lesson is going to be relatively short, and I don't think you'll find it difficult at all, so let's go ahead and jump in. Okay, first of all, let's get a definition for the word polynomial. A polynomial in X is either a term or the sum of a finite number of terms in the form ax to the n power, where a is any coefficient and n is any positive integer. So here's an example of a polynomial, something like 16x to the 8th minus 7x to the 6th plus 5x to the 4th minus 3x squared plus 4. So this is a polynomial because it's a sum of a finite number of terms and the powers on the variables are all positive integers. Now this one happens to be written in what we call descending order, meaning that the powers on the variables start with the largest and go to the smallest. Now here are a couple of expressions that are not polynomials. 2x to the third minus x squared plus 4 over x would not be a polynomial because this last term is not in this form. And also 2x to the third minus x squared plus 4x to the negative 1 would not be considered a polynomial because even though it does look like it's in this form, the exponents are not all greater than or equal to 0. So this negative exponent is what disqualifies this from being a polynomial. Notice, by the way, that these two polynomials are exactly the same. It's just that these last two terms look different because with this one we have x to the negative first in the top, and with this one we've used the negative exponent rule to move that x to the bottom. But anyway, neither one of these is a polynomial. Now, polynomials are usually written in descending order, as I mentioned before, meaning that the exponents on the variable decrease from left to right. A polynomial can actually use any variable, and we can have terms with more than one variable as well. And sometimes we'll talk about the degree of a term or the degree of a polynomial. So the degree of a term is the sum of all the exponents of the variables in that term. And the degree of a polynomial is just the largest degree of any non-zero term in the polynomial. So let's practice a little bit. Here is a single term. This is 3x to the 4th. The degree of this term would be 4 because that's the exponent on the variable. Now look over here and you see a polynomial that contains 3x to the 4th. The degree of the terms here is 4, 2, and 0 because this one doesn't have a variable, so its degree is 0. So the degree of the polynomial is the same as that of the term with the largest degree. So since our degrees here are 4, 2, and 0, the degree of the polynomial is 4. Here we have a term 5x, or we know that that could also be written as 5x to the first. So the degree of this term is 1. And when you look over here at this polynomial, 5x plus 7, the degree of this term is 1, and the degree of this term is 0. So the largest degree of any term in this polynomial is 1. Here we have a constant, negative 7. And that could also be written as negative 7 times x to the 0 because I'm sure you remember that x to the 0 is 1. So any constant can be written as that number times x to the 0. And so the degree of a constant is 0. And when we look at this polynomial, the degree of the terms in this polynomial is 5, 6, and 0. So the overall degree of this whole polynomial is 6. Remember, the degree of the polynomial is just the largest degree of any one term. Now here is a term that contains two variables. So this one says 2x squared y. or in other words, we could say 2x squared y to the first. So if you have more than one variable, then to get the degree of that term, just add the exponents together. 2 plus 1 is 3, so the degree of this term is 3. Now when we look at this polynomial, the degree of this first term is 1 plus 1, which is 2. The degree of this second term is also 2, and the degree of this last term is 3. So the largest of those degrees is 3. So the degree of the polynomial overall is 3. Now let's talk about a few special kinds of polynomials. A polynomial that has exactly one term is called a monomial. Because I'm sure you're aware, the prefix mono means one, as in monorail. And a polynomial with exactly two terms is called a binomial, because you know the prefix bi means two, like in the word bicycle. And a polynomial with exactly three terms is called a trinomial, because the prefix tri means three, as in the word triangle. So here's example 1, and it says for each polynomial, first simplify if possible, then give the degree, and tell whether the simplified polynomial is a monomial, a binomial, a trinomial, or none of these. Okay, so our first polynomial is 2x to the third plus 5. The first term has a degree of 3, the second term has a degree of 0. Out of those two, the largest is 3, so the degree of this polynomial is 3. And since there are two terms here, this is a binomial. On part B, we have 6x minus 8x plus 13x. Since these are all like terms, we should combine them before we try to answer the questions. So 6x minus 8x would be negative 2x, and negative 2x plus 13x would be 11x. So there's only one term here, and the exponent on this variable is a 1. So the degree of that term is 1. And because it's only one term, that is a monomial. On part C, we have 4xy minus 5xy plus 2xy. Because these are like terms, we should combine the terms before we try to classify anything. So 4xy minus 5xy is negative 1xy, and negative 1xy plus 2xy is 1xy. Now, this term has two variables, so remember the degree is going to be the sum of the exponents on the variables. So the exponents here are 1 and 1, so the sum of those two exponents is 2, and therefore the degree is 2. And because this is only one term, this is a monomial. On part D, we have 2x squared minus 3x plus 8x minus 12. Now notice that the two middle terms can be combined. Negative 3x plus 8x is positive 5x. So we could write this expression as 2x squared plus 5x minus 12. There are three terms here. The degrees on these terms are 2, 1, and 0. So the largest degree of any one term is 2, and therefore the degree of the polynomial is 2. And because there are three terms, this is a trinomial. Now we're going to practice evaluating polynomials. And you'll remember from chapter 1 that to evaluate means to plug in the given value for the variable and then simplify using order of operations. So let's take the polynomial 3x to the fourth plus 5x to the third minus 4x minus 4. And let's evaluate that for x equals negative 2. So all we need to do is plug in negative 2 everywhere there's a variable. So that's going to give us 3 times negative 2 to the fourth, plus 5 times negative 2 to the third, minus 4 times negative 2, minus 4. Now let's go back and use order of operations. So remember, order of operations is PEMDAS. First, we do any operations that are inside parentheses. We do have some parentheses, but they're really acting like multiplication symbols. There's really not anything to do inside those parentheses. Then we handle exponents. So the exponents here are negative 2 to the fourth and negative 2 to the third. So let's evaluate those next. So negative 2 to the fourth would be negative 2 times negative 2 times negative 2 times negative 2. that's going to be positive 16. So this term will become 3 times positive 16. Then we have plus 5 times negative 2 to the third. So negative 2 to the third is going to make negative 8. I'll let you multiply that out. And then I'm just going to copy the rest of this. Let's go ahead now and do the multiplication within each term. 3 times 16 is 48. 5 times negative 8 is negative 40. So let's just write minus 40. Negative 4 times negative 2 is positive 8. And then we have our minus 4. Now we can just go through and add from left to right. 48 minus 40 is 8. 8 plus 8 is 16. And 16 minus 4 is 12. In part B, they're asking us to use the same polynomial, but this time evaluate for x equals 3. So I'll copy it down again, but this time I'll substitute 3 in the place of the variable. So that's going to make 3 times 3 to the 4th power, plus 5 times 3 to the 3rd power, minus 4 times 3, minus 4. Okay, so again, we go back and we take care of exponents first. 3 to the 4th power is 81. And 3 to the 3rd power is 27. And then we take care of multiplication. 3 times 81 is 243. 5 times 27 is 135. And 4 times 3 is 12. And now adding from left to right. 243 plus 135 is going to be 378. 378 minus 12 is going to be 366. And 366 minus 4 is going to be 362. Now we're ready to start adding polynomials. You're going to like this because to add two polynomials, all we have to do is combine like terms, and we're used to doing that anyway. So in example 3, they want us to find the sum of these two polynomials, but let's take this opportunity to add these polynomials vertically. So we're going to copy these two polynomials down and we're going to line up the like terms vertically, kind of the way you would line up a 2 or 3 digit addition problem vertically. And then we just have to combine like terms. So 6x to the third minus 2x to the third would be positive 4x to the third. Negative 4x to the second plus 7x to the second would be positive 3x to the second. And positive 3 minus 5 would be negative 2. So this is the sum of these two polynomials. Now let's do the same thing for part B. We'll have 2x squared minus 4x plus 3, and we want to add x to the third plus 5x. Now if we line these up vertically, notice that there is nowhere to put x to the third, so I'm going to put it out here to the left of the x squared column. And then the 5x is like this term, so I'm going to put 5x under that term. And see, the point is to line up all of your like terms, and then we can add. We'll have x to the third plus 2x squared, and then we have minus 4x plus 5x. That's going to add up to positive 1x, and then we have our constant plus 3. Now notice that you don't have to copy the terms down vertically. You can just add horizontally if you're comfortable with that. You can just look across here for all of your x to the third terms. Here I have positive 6x to the third and negative 2x to the third. That makes 4x to the third. And then our x squared terms are negative 4x squared and positive 7x squared. Together they make 3x squared. And then our constants are positive 3 and negative 5. Together they make negative 2. And on part B, we can say, well, we're going to start with the largest exponent, which would be 1x to the third. And then we only have one x squared term, that's positive 2x squared. Then we have two x terms, negative 4x and positive 5x. Together they make positive 1x. And then we have our constant. So you can use the vertical format or you can use the horizontal format, whichever you find more convenient for yourself. Now we're ready to subtract polynomials. And to subtract, we're still combining like terms, but we do need to remove these parentheses first by distributing this negative sign. So notice that the parentheses on this first polynomial are not really accomplishing anything. So I can leave those off, and now I can distribute this minus sign. This would make these last two terms minus 3x and plus 8. Remember, distributing a minus just changes the signs of all the terms that were inside the second pair of parentheses. And now we can combine our like terms. 5x and minus 3x together make 2x. Negative 2 and positive 8 together make positive 6. Now on part B, be careful to read this very closely. It says subtract this polynomial from this polynomial. If you'll remember back to chapter 1, when we were talking about how to translate word phrases into subtraction, subtract this from that means that that has to come first. So if we're taking this away, it means we had to start with that. So we'll have 11x to the third plus 2x squared minus 8 minus 6x to the third minus 4x squared plus 2. Now we'll need to eliminate these parentheses by distributing the minus sign. That's going to give us 11x to the third plus 2x squared minus 8 minus 6x to the third plus 4x squared minus 2. Now we can combine our like terms. Let's just look through here and find all of our x to the third terms. So we have 11x to the third and negative 6x to the third. Together those make 5x to the third. Then for our x squared terms, we have 2x squared and positive 4x squared. Together they make positive 6x squared. Then for our constants, we have negative 8 and negative 2. Add those together and you get negative 10. So I'm going to write here minus 10. And that's all there is to subtraction. Now for example 6, we're going to do one more subtraction, but notice that we can write this vertically the same way that we wrote the addition vertically. You could just start by writing down your first polynomial, and then when you write down the second polynomial, just make sure to change every sign. So this would be negative 2y cubed, positive 7y squared, positive 4y, and negative 6. Now we can combine our like terms. And by changing all the signs here, what we were basically doing is distributing that minus. So now we're ready to combine. 14y to the third minus 2y to the third would make 12y to the third. Negative 6y squared plus 7y squared would make positive 1y squared. Notice that because the coefficient is a 1, I did not write it, but it's understood. And then we have positive 2y plus 4y, that's going to be positive 6y. And then we have negative 5 minus 6, that's going to add up to negative 11. And so our final polynomial is 12y to the third plus y squared plus 6y minus 11. Now for example 7, we have three polynomials, and we have 4 minus x plus 3x squared as our first polynomial, and then minus 2 minus 3x plus 5x squared, then plus 8 plus 2x minus 4x squared. And I don't want you to be intimidated because there are three polynomials here. It's really not such a big deal. I think the best thing to do, maybe because we have so many terms, is go ahead and write these down in a vertical format. And don't forget that the second polynomial is being subtracted, so as we copy the second one down, we'll make sure and change all the signs so that we distribute this minus. So let's start by copying down 4 minus x plus 3x squared, and then we're going to distribute this minus, so we'll have negative 2 plus 3x minus 5x squared, and then this one is added, so we'll just copy it down the way it is, 8 plus 2x minus 4x squared. Now we're ready to just combine our like terms, starting with the constants here. 4 minus 2 is 2, and then 2 plus 8 is 10. And then on the x terms, we have negative 1x plus 3x, that adds up to positive 2x. And then positive 2x plus 2x gives us a positive 4x. Then on the x squared terms, positive 3x squared minus 5x squared would be negative 2x squared. And then negative 2x squared minus 4x squared would be negative 6x squared. So here is our polynomial, and notice that this one is not written in descending order. This one actually has the terms backwards from descending order. So it starts with the constant, then it has the x term, then it has the x squared term. There's nothing wrong with having the polynomial in ascending order instead of descending order, but most of the time we do have them in descending order. So if you entered this answer into MyLabs Plus as negative 6x squared plus 4x plus 10, that would be perfectly fine and just as acceptable as this order. So in a polynomial, remember that the order of the terms does not affect the value of the expression, but just to make things easy to read, we normally do write them in descending order. Now for our last example, we'll look at some polynomials that have two variables. But nothing is going to change here because we're still just adding and subtracting, and that still means we're just combining like terms. Polynomials with more than one variable are added and subtracted by combining like terms, the same as single variable polynomials. So in part A we have an addition problem, and on part B we have a subtraction. Let's just go through them together. Here we have 4a plus 2ab minus b plus 3a minus ab plus b. Okay, for the a terms, we have 4a plus 3a, that's going to be 7a. Then for the ab terms, we have 2ab minus 1ab, that's positive 1ab. Then we have negative b plus b, and that actually would add up to 0, so there will not be another term here. On part B, we have 2x squared y plus 3xy plus y squared minus 3x squared y minus xy minus 2y squared. Now, you know I like to distribute that minus sign and recopy everything as we go. So that's going to give us 2x squared y plus 3xy plus y squared. Then minus 3x squared y plus xy plus 2y squared. And now let's just carefully combine the like terms. There's no right or wrong order here, so I'm just going to start with the x squared y terms because that comes first, and honestly it doesn't matter what order you do them in. So here I have 2x squared y minus 3x squared y. Together that adds up to negative 1x squared y. And notice that I did not write the 1, but I just wrote the negative in front of the x squared y. Then let's do our xy terms. So we have positive 3xy plus 1xy. Together they make positive 4xy. And then the y squared terms are all that's left. 1y squared plus 2y squared is positive 3y squared. So here is our final polynomial for part B.